Next, let's talk about liquids. So liquid particles are also in motion. Liquid particles are free to slide past one another. They have a property called flow. Gases have this as well. It just means that the particles can slip and slide past one another. However, liquid particles are attracted to each other, whereas gases were not. The particles of a liquid can spin and vibrate while they move, and this contributes to their average kinetic energy. But most particles don't have enough energy to escape into the gaseous state. They would have to overcome the intermolecular forces of attractions with the other particles that they're next to. So as these liquid particles can slide past one another or flow, they're still connected. What's holding them together are IMFs, or intermolecular forces of attraction. But if I was to add heat to these liquid particles, they would shake and they would vibrate. Those vibrations would become severe enough to overcome those intermolecular forces, and those liquids would escape into the gaseous state. Liquids are also more dense than gases. So when we see in this particle diagram here, there's a lot of space in between these gas particles, and we could squeeze the top down and get those gas particles closer to one another. But if this was a liquid and I squeeze the top down or increase the pressure, it's not really going to have an effect on the volume. Liquids are, we call it condensed state of matter, along with solids. Increasing pressure hardly affects the volume. Liquids can turn into a gas two different ways. So if we had a little container here and it was filled with liquid and we just let it sit out, the natural ambient temperature and the sunlight would hit it, and eventually some of those particles would gain enough kinetic energy and escape into the gaseous state. And we would call that process evaporation. But if I added heat to the liquid particles and they gained enough kinetic energy to overcome those intermolecular forces, maybe they would all escape, or eventually they would all escape. That process of adding heat to convert liquid to a gas is called boiling, or in other words, vaporization. So if this evaporation happens in a closed container, what happens, these liquid particles start to push against the sides of the container. We call that force vapor pressure. Eventually, some of those liquids are going to come in contact with one another, and intermolecular forces are going to pick back up, and they're going to condense back out to a liquid. Condensation is just the conversion of a gas state to a liquid state. It doesn't mean it stops moving. If we're still adding heat in this container, some of the particles are going to vaporize and go back into a gas, and some of them are going to condense and go back into a liquid. But at the point where the rate of evaporation equals the rate of condensation, we call that a dynamic equilibrium. And that will always be achieved in a closed container. You have a gas layer on top and a liquid layer on bottom, and the rates will eventually equal out. Obviously, if we increase the temperature, this is going to increase the vapor pressure. If I add a lot of heat to this closed container, those particles are going to push against the sides of the container with a greater force, making greater vapor pressure. This is why you don't want to throw condensed gases into like a fire or something like that. You don't want to store spray paint in a really hot place, because the vapor pressure could get so severe that it could break open the container and it could explode. So we know that the rate of evaporation from an open container increases as heat is added, because the heating allows larger numbers of particles at the liquid surface to overcome the attractive forces that were holding them together as a liquid. Heating also allows the average kinetic energy of all the particles to increase. So when is the point where we add enough heat where we stop evaporating the liquid and start vaporizing or boiling the liquid? We're going to talk about that in the next video. So in summary, what we've learned is that you should know some of the basic properties of liquids, like that they flow and they have intermolecular forces of attraction that hold them together, and they're condensed states of matter. You should also know what happens when we heat them in open and closed containers.